In this video, we're going to go over what is the period of the motion and how to derive velocity from the period. Now, this is more of a subtopic of circular motion, but nevertheless, it is a very important concept because without it, you will not be able to solve a lot of the circular motion problems. So it'll be a pretty quick lesson, so stick with me as we talk about where this formula comes from. So first of all, the velocity of an object that is moving in a circle is constant. And for the constant motion, if you have worked through kinematics, right, you saw that when we're talking about constant velocity, our equation for motion is pretty simple. It's just distance is equal to velocity times time. So we can rearrange it. So write that velocity, if we divide both sides by time, is equal to distance divided by time. Now, if we define period as the time it takes for the object to complete one revolution, that is, go around the circle once, then the distance that it covers by going around the circle once is simply circumference of a circle. And the formula for circumference of the circle is 2 pi r. Here, we basically derive our equation for the velocity given the period and the radius of the circle. So the reason why this equation is in most classes is not given on the equation sheet because you can quite simply derive it yourself, right? But nevertheless, it's very important because in a lot of these problems, you will be given the period, and from the period, you have to know how to calculate the velocity. So let's go over two really quick problems to for me to demonstrate you how this equation works. In the first problem, a ball is attached to a string, and it does one complete revolution in 5 seconds. So when they're saying one complete revolution, what they mean is that the period is 5 seconds. The string is 1 meter long, so that's the radius of the rotation, and we have to find out the centripetal acceleration. So let's start with the formula for centripetal acceleration, which is given on your equation sheets. So it's equal to v squared over r. Now, of course, here in this formula, we don't know the velocity, but the velocity we can find from this formula above here. That is equal to 2 pi r over time, right? So 2 pi times 1 meter divided by 5 seconds. We get an answer once we plug this into a calculator of 1.25 meters per second. Then plugging it back into our equation for acceleration, 1.25 squared over 1 is going to be 1.56 meters per second squared. So as you can see, pretty simple, pretty straightforward problem, but you need to keep in mind that there is this equation. Let's just go over one more problem for this video, really quick one. In this problem, you'll be given the centripetal acceleration, right, of 3 meters per second squared. And you'll be given the radius. So a cat sits 2 meters from the center of a merry-go-round. The cat's centripetal acceleration is 3 meters per second squared. How long does it take for it to go around once? So again, you need to understand this phrasing, right? How long does it take to complete one revolution is what they're asking. So they're asking about period, right? Of course, as before, we'll start with the formula for centripetal acceleration as v squared over r. And we can find the velocity, right? Because we know the radius and we know the acceleration. So let me multiply both sides by radius and take a square root of both sides to cancel out the square. So square root of 3 times 2, square root of 6 is going to be 2.45 meters per second. Just like in the previous problem, I will pull up the new equation that we learned. And but now I'll rearrange it for the period. So I'll multiply both sides by t and divide both sides by velocity, right? Because I just want to isolate the period. So let's plug this in, 2 pi times 2 meters divided by velocity, which is going to be 2.45. And we get an answer that is equal to 5.13 seconds. All right. So hopefully this was helpful. You should keep this equation in mind and keep watching these videos because in the next video, I'm going to go over two very, very important problems in centripetal motion that are very likely to show up on your quizzes and tests. So keep practicing and keep watching these videos on your way to an A. Thank you.